Hi everyone, welcome to the presentation of Comparative Study of Solar Irradiation Models. The solar energy is one of the fastest growing renewable energy sources. The satellites and weather station measure the solar radiation that travels to the Earth. The available data are limited to a few locations or to short periods of time. The solar energy-based system like photovoltaic and thermal systems and areas like agriculture and thermal comfort need solar radiation records. The fraction solar radiation that is scattered across the sky and reaches the Earth's surface is called diffuse radiation. The radiation that is not dispersed or absorbed and directly reaches the Earth's surface is called direct or beam radiation. The global horizontal irradiation is the sum of the direct irradiation and diffuse horizontal irradiation. A lot of side A-based only global irradiation and horizontal planes are available as most systems using solar energy are tilted. It is obvious that these data are not sufficient. Actually, diffuse irradiance and B-normal irradiance are measured mostly by research institutions due to the high cost involved with necessary equipment. A lot of sites embed only global irradiation and horizontal planes are available. As most systems using solar energy are tilted, it is obvious that these data are not sufficient. Actually, diffuse irradiance and normal irradiance are measured mostly by research institutions due to the high cost involved with the necessary equipment. By implementation of models it is possible to determine the global irradiance on a tile surface. The decomposition model uses the global horizontal irradiance to break it down into the direct and diffuse irradiance. Insofar as the transposition model uses these values and the global horizontal irradiance data to establish the solar radiation on Earth's surface. The objective of this work is to assess different possible combinations among for decomposition and for transposition models, with the result obtained by software producer for Porto Alegre city in Brazil. The present work consists of the three main steps. 1. Determination of the diffuse horizontal irradiance and direct normal irradiance from global horizontal through the decomposition models. 2. Determination of the global tilted irradiance by means of the transposition models. 3. Evaluation of system combination and decomposition transposition models and comparison with the result obtained with the software radiosol 2 at a third angle of the Earth. Data. The data selected for this work was obtained from solar and wind energy resource assessment in periods of 1 hour for more than 10 years in the national territory of Brazil. The uncertainties may be significative near to sunset and sunrise. This is related to the value obtained for, for the cosine and the mask effect of the surrounding moon that introduce Earth in these zones. De Michel and Norton proposed the use of the quality control criteria. The data that does not comply with the condition showed equation 1 will not be considered for the calculation and validation. The, the accuracy of the different combination models will be assessed and compared to the values obtained from the software reducer to in terms of statistical indicators that have been widely adopted in the literature. These statistical indicators are presented below. The root mean square error, allowed to determine the short-term performance of the correlation. The mean, the mean bias error provides information on the performance of the models over a long-term period. The R-squared coefficient represents the fraction of the variability that is accounted for by the model when it is compared to a dataset. The decomposition model can be empirical models, such as Earth orbit and rate, which are based in correlation relating either the clear index or direct beam transmittance with the diffuse fraction. This model is considered as a quasi-physical model. Therefore, it uses physical principles together with the empirical correlation. The transposition model generally converts the global horizontal irradiance into global terrestrial irradiance. It is the sum of the three components, namely the diffuse radiation, the beam radiation, and the ground reflective radiation. The beam irradiation and the turtle surface can be determined through the geometric relation by considering the incidence angle data, as shown in equation A. Ground reflect, reflective irradiation can be determined by means of isotropic models through sample algorithm, as given by equation 9. The diffuse component can be divided into three diffuse irradiation: the isotropic diffuse irradiation, the circumsolar diffuse irradiation, and the aeration brightening diffuse irradiation. This model can be classified in isotropic and anisotropic models. The table 2 presents the transposition model that will be considered in this study. Two isotropic models, Ornakis and Badescu, and two anisotropic models, Crucial and Perez. These models were selected because they are widely cited in the literature. The result obtained of the statistical estimator in the comparison between the combination models and software are shown in the table 3. In case of error and seeing, the error range is between 26.49 and 108.883 watt square meter for the Orville Perez and disclosure models respectively, while the MBE ranges from left 9.915 to left 105.765 watt square meter for the Hertz, Perez and disclosure models respectively. All models represent the variability with an accuracy of more than 99% with respect to the values obtained by the radiosol 2 software, except for the models that use the closure models. The figure 2a shows the result of RNCE and MBE, and their relative part is shown in figure 2b. The graph depicted on figure 2 shows similar behaviors among the transposition models when they are used with different decomposition models. The statistical estimator depends more on the transposition model used than on the decomposition models. On the other hand, the anisotropic models, Cloutier and Perez, tend to overestimate the irradiance MBE greater than zero, but the results obtained in the present article show that all models underestimate the data provided by the software. A literature review was carried out in order to compare the results obtained in the present study with these obtained by other authors. They are shown in the table 4. It is observed that this Koronakis combination tested for Ahasio by Norton underestimated irradiance presenting an relative MBE of less 5.88% and a relative RCE of 9.989%. These results are similar to those obtained in the present world for Porto Alegre. For example, in the present world a relative MBE of less 5.13% and relative RNCE of 7.6% were obtained. Figure 3 compares only readings obtained by the Radiosol 2 software with the readings calculated by the models with best accuracy at each degree slope. The red line represents the best linear fit of the data. The results indicate a good performance when compared to the software result. A R-squared of 0.9979 was obtained for Hertz Perez and Orville Perez models, and 0.9983 for Orville Perez models. It is important to point out that the model used by Radiosol 2 software for the decomposition was developed by Collares Pereira and Hall. This is similar to Hertz, Orville, and Reid models, and the transposition model is by pairs. Since these models combine physical principles, it presents the higher deviation when compared to the software result. The pairs model implemented in this work use brightness coefficients which are not used in the pairs model implemented in the Radiosol 2 software. Conclusion: the main objective of the present work was to evaluate the performance of the different combinations of the sum of the multi-sided model that determine global Fourier irradiance and an inclined surface, to choose models that have good accuracy. System combination of decomposition transposition models were and the three best combinations among them were identified. There are the Earth pairs, Orchid pairs, and Rain pairs models. They have a relative RNC between 5.68% and 6.13%, and a relative MBE from left 2.15% to left 2.47%, therefore presenting similar accuracy than these models present in the literature. Future studies involving the evaluation of potential applications of solar energy systems in Porto Alegre can use these three models since they have shown accurate results.